Welcome to Man Does Tech, where I solve the problems you didn't even know you had.
You start by verifying power and wiring because a wrong voltage fries modules. Check the label, then select 3V or 5V regulator. Next, connect the module TX pin to your board RX and RX to TX while sharing ground. Once done, open a serial terminal at 9600 to 115,200 baud. This gives instant raw NME messages. Make sure to enable 5V tolerant pins if needed, and power on. You're now ready to receive sentences and confirm a working link. You'll configure the GPS for reliable fixes and readable output. Send simple configuration commands to set NME sentences or a binary protocol. Then parse core sentences like GGA and RMC to extract fix quality, UTC time, latitude/longitude, and speed. If you want easier coding, import Tiny GPS++ or Neo GPS. They handle parsing and converting to degrees. Once parsed, convert coordinates to your map projection or log them. Make sure to set an appropriate update rate. Typically, you finish by validating real-world performance. Move outside, wait for a 3D fix, and watch time to first fix. Then implement basic filtering. Discard fixes with high HDOP or invalid fix type so your app doesn't use junk positions. Once done, log positions to storage or stream them over telemetry. If you run into problems, first check antenna seating and horizon visibility, then verify serial settings and power stability. That one key troubleshooting step, ensure a clear sky view, fixes most issues quickly.
Thanks for watching. If you found this helpful, don't forget to like and subscribe.